Please welcome Edward Hiserodt.
Well, after Bill's talk, I'm so depressed I don't know if I can even go on.
Not the uranium, though.
I guess I'll have to start out with a joke then. Let's see. These two atoms walked in a bar, and one of them turned to the other one and said, "I've lost my electron." And the other one said, "Are you sure?" And the first one said, "I'm positive." Hey, I didn't expect that. I mean, I told that at the American, the Northwest Association of Physics Teachers, college physics teachers, when they rolled in the house, but I didn't think anybody here would get it. Some of you probably really didn't, so let's talk about it for a minute. Atoms have an electrical balance between the number of electrons and the number of protons. And if an electron is stripped away from an atom, then the atom is now positive, and that's what the joke was all about. For those that you didn't get it the first time, you can laugh now. We're talking about ionizing radiation. That's what I want to talk about tonight, this afternoon. And we're not talking about microwaves. We're not talking about infrared radiation. We're not talking about ultraviolet radiation, although that is the next door neighbor to ionizing radiation. We're talking about the radiation that we normally call atomic radiation or nuclear radiation, which really is ionizing radiation, which will strip that electron away from that proton. Down, right?
Yeah. Can you see that?
Hey. Okay, here is our enemy right here. This is the theory that has been used for the safety practices regarding radiation in the United States for the last 60 years. And it's called the linear no threshold theory. And this says that your risk increases with your exposure to radiation linearly. The more exposure you have, the worse you're going to be. It's a linear relationship. Therefore, there is no amount of radiation that's safe. If every bit of it is going to give you more of an increased risk, then there's no amount that's safe. Now, we really don't see this in nature very often. We can take its next door neighbor, ultraviolet radiation. We know that we need a little bit of ultraviolet radiation to stimulate vitamin D in our skin. But if we get too much, we get sunburned. We increase our chances for cancer. If we're staked down by the Indians in the desert, then we get way too much and it's fatal. So most radiations and most other things follow along this way. Okay, let's look at some of the units about radiation, because for us to not be afraid of radiation, not to have what we call radiophobia, is for us to understand a little bit about radiation. The unit that we use in the United States primarily is called the rem, or Röntgen equivalent man. And 1,000 millirems is equal to 1 rem. And you'll hear millirems more than anything else. The average exposure of people in the United States is 360 millirems. It's about twice that if you're on the Colorado Plateau. So remember that, it's about 1 millirem a day. Okay, if now radiation follows the linear no threshold theory, then we should be able to look around and we should be able to see communities that have higher radiation and that they should have more cancer. They should have worse lives. But let's see if that's indeed true. Sleeping with your spouse gives you about 1 millirem a year. Now, Edward Teller once said, sleeping with one woman is okay, but with two is very, very dangerous. A coast-to-coast jet flight, 5 millirems. Now, they kicked all the people out of the area around Chernobyl at 500 millirems. Now, there was a man, Zbigniew Jaworski, who was head of the United Nations. Believe it or not, in this case, the United Nations happened to be right. Their radiation committee that said, why don't we evacuate Norway? Because Norway's radiation is higher than it was around Chernobyl. Radiation sickness kicks in for 50% of the people at about 100,000 millirems, which is 100 rems. Death occurs for 50% of the people at about 400,000 millirems. So that gives you some kind of idea of how much radiation it takes to really do you in. Now, we were talking about Chernobyl. This is the welcoming committee at Pripyat, Ukraine, where they're welcoming you there to come on into the evacuation zone, which is here. You can see the radiation was so terrible there that it stripped all the leaves off the trees. Unfortunately, they came back. You know, Greenpeace hates that. They wanted them to stay gone. Now, this gives you some kind of idea of what the evacuation in Chernobyl. The line, the dotted line toward the bottom, shows what the cutoff level was to ship these poor people out of their homes into these tents. By the way, their tent cities are getting better. As they commit suicide, they go into the better tents. There's more, the quality of the tents go up. This gives you some kind of idea of the amount of radiation that we see around the world in some places compared to what they ship these poor souls out in Chernobyl. Okay, let's look for a minute just about the types of radiation, because they have different effects. Alpha radiation that you would get from uranium or plutonium or these things that sound terrible won't even penetrate your skin. It's only a couple of inches of air. Beta rays are actually just electrons. I guess some of the ones that were, missing in the bar someplace, but they're going pretty fast. They're close to the speed of light. They can cause burns on your skin, but basically they're not much. Gamma and X-rays are what we tend to fear because they have such penetration powers. Okay, so does anybody remember one of these?
Oh, yeah.
All right. See, for those of you that don't, over on the right bottom down there, that's where you put your feet. Now, one of those little sight things was where the shoe man looked to see about your shoe size. And your mama was in the other one. And she was going to make sure that those kids were going to, work out before they wore out. So anyway, this machine gave you 175 millirems. How many do we have in a year? 360. It's just about exactly a half of your year's radiation. How many times did you use this machine when you were a kid? You press the button as many times as you could because you could see your toes wiggling, and it was kind of an exciting thing to see your, sort of like having X-ray vision to be able to see your toes. So now what about the shoe people? It seems like they would have all, if this thing about the linear no threshold theory was true, they would all be keeled over dead. Well, one of them came up to me after a talk in Portland and said, I used to work one of those machines, and I'd do about 20 of them a day. And it didn't seem to bother him. He had two heads, but except for that. Now, as we were saying, if it were true, the linear no threshold theory were true, then we would see where there was a higher level of radiation, we'd have more cancer. Now, this gives you two different places: the Colorado Plateau, which I'm planning to move to as soon as possible, and the Gulf Coast states where I grew up. You can see that the radiation level, which is the bar graph, is much higher in the Rocky Mountain states. But the cancer level is lower. Now, how can that be? Well, it can't be if the LNT is true. Now, that dog is a special dog. He's trained to get radiation victims off the beaches at Guadalupe Beach and drag them to Venezuela. because of the searing radiation on this beach. Actually, it is pretty searing. How many millirems do we have in the United States? How many per year? How many? 360. Okay. How about 26,300 on that beach? That's why the dog has to drag those dead bodies away. Actually, they don't. What does happen on the beach is that people dig up the sand, even though it's illegal. They take it home and they stick it under their bed. Why? Because it's sort of a health thing that has developed over the years. They found out it benefits their health and their well-being. So they're not supposed to steal the sand, but they do. But we do not see an increase in cancer there. Now, if you really want to get some good, solid radiation, Ramazar, Iran is the place to go. If you might want other reasons to go there, but just to give you an idea, there, 48,000 millirems a year. Now, if the LNT were true, I mean, there wouldn't be a soul living in Ramazar, Iran, but it doesn't seem to bother him. Anybody remember him?
Oh, yeah.
I agree. I was fortunate enough to be in this city with this man, Robert Welch, and Larry McDonald in the same room. I mean, what a rush. What a wonderful thing. And he and Robert Welch, I think, are probably the brightest minds of the 20th century. Peter Beckman sort of started me on the road to being up here tonight because of a newsletter he wrote. If you try to read that, you'll die before you get through because your eyes will be ruined completely. But this was a newsletter where he talked about research done by a man named T.D. Luckey, or Thomas Luckey. And Dr. Luckey, at that time, was head of biochemistry department at the University of Missouri Medical School. And he wrote a book about hormesis. And what is that? Well, hormesis is like a vitamin. You take a little bit of vitamin A, you get better. I mean, it helps your health. You take a little bit more, it really doesn't do anything for you. You take a whole lot, it makes you sick, and you take a whole lot, and it kills you. So hormesis is the stimulatory actions of an agent, which at low levels has a different effect than at high levels. And that was when this book came out and was announced by Peter Beckman, I said, this is going to be the biggest story of the century. It is, it's going to be all over the front pages tomorrow. Well, you know how that works. There wasn't a mention. He later on wrote another book 10 years later and was even more about hormesis. I expected, after Dr. Beckman's Health Hazards of Not Going Nuclear, which is one of the best books ever written, in my opinion, I expected him to write a book on hormesis, but the Reaper got him. He died before he could do that. Now this is Dr. Luckey. Let me see if I have something about him here. He's still active in research. Now, except for one night a year, when he leaves Mrs. Claus and goes out to deliver toys to all the good little boys and girls. Now, he and Dr. Beckman were good friends. He lived in Fort Collins, and Peter Beckman lived in Boulder, and they got together quite a bit. And he was one that really formulated this theory of hormesis. Now, this would be a typical hormesis curve. Over on the left side, you would have a normal amount of something like, for instance, if you had a vitamin deficiency and you were at that point, then more vitamins would help you, health being in the negative direction in this case. And then as you took more vitamins, well, it really doesn't help you. And until you get to a point, what's called the zero equivalent point there, and then the action of the agent starts being harmful. Now, this occurs not just with vitamins, but it occurs with the trace minerals like selenium or arsenic that we must have, but we must not have too much of them. This was one of the things that started the hormesis revolution. And this was looking at the death rates of the survivors of the Hiroshima and Nagasaki attacks. This is the same curve we looked at a minute ago as the hormesis curve. You can see that up as down to about somewhere around 5 millirems. Those are 5 rems. A centigrade and a rem are the same thing. So those values on the bottom you need to multiply by 1,000 to get them into millirems. But you can see that there was a benefit in health until you got to about 80,000 millirems. And then the LNT does kick in, and your health does get worse with additional radiation. But in that lower area, there is a significant health benefit from radiation. Now, I want to give you an example of a study that was done in 1989. Now, this study, nor the next two that I'm going to point out, was not done to try to examine this theory that I'm talking about hormesis. As a matter of fact, it was the exact opposite. All 3 of the studies that I'm going to touch on were done to show how radiation was harmful, and accidentally showed that it wasn't. Okay, this study was done with 31,000 women in Canada. There were some that were X-rayed. They were fluoroscoped facing the fluoroscopy machine. They had significantly high cancer rates. I think it was 25 times, did it say? 25 times more radiation when you faced it. Now, here you might say is the curve that they would show you, and this proved that the LNT was true. That as the exposure goes up, and again that's in rems, so all those would be thousands of millirems. You would see that the relative risk of death to breast cancer goes up too, except they forgot to put those parts of the curve in there, and you can see that there is a very significant decrease in the cancer death rate for these women that were exposed for lesser amounts than the ones that were facing the machine. Now, I'm going to read this to you in case you can't read, can't see that far or whatever. By the way, a rad, a rem, a centigrade, and a centisievert, when you're talking about X-rays or gamma rays, is the same. So we would take those values at 15 rad or 15 rem. We talk about 15,000 millirems. So at 15,000 millirems, there was a reduction of cancer mortality by 34%. At 25 rad rems, it was 15%. When you got above 40,000 millirems, then it started going the other way on you. And then above 100 rad, the LNT became true. Can I back this up? Is there anybody smart enough to know how to back one of these up? Up? Oh, that's right. So the values they're talking about, the first one there, the 15 rad, you can see, or 15 centigrade. You can see where the major reduction was, and it continued to be below the unitary point up to about somewhere around 40,000 millirems. Now, pardon, we're close? Okay. The decreased rate, this is from Myron Polykov, who is the visiting fellow on the Nuclear Regulatory Committee. He said the decreased rate of breast cancer produced by low-dose, low-level radiation, were rejected out of hand by a choice of mathematical models that extrapolates the low-dose radiation from high-dose to low-dose exposure. In other words, they were using the LNT. Now, they predict 900 excess deaths based on the LNT, but he says that with a 99% confidence limit, that instead of causing 900 deaths, it would save 10,000 deaths of 1 million women that were exposed to radiation like this. Now, this was brought to the attention of the American Cancer Society. I've got a quote from one of their people that says, "That is not the way we get our people tenure." if you've not been a big fan of the American, so, okay. A couple of more quick studies. You know how horrible radon in the home is because we're getting public service announcements, right? If it's over 4 picocuries per liter, you better do something about it. This was a study done by Bernie Cohen at the University of Pittsburgh. If you'll see the dots there, those are data points, and they are an average of 89 counties, not people, 89 counties. This was 90% of the people in the United States. The LNT would show cancer going up with the increased radon. In truth, it goes down. By the way, the spas at Bad Gastein have advertised the fact that they have 4 nanocuries per liter, which is 1,000 times what they're talking about here. And people flock there and have been for many years. Do I have 2 more minutes? 2 minutes. 2 minutes. Okay. This was probably the biggest study on radiation ever done about the effects. These were on 700,000 shipyard workers. Let's just look at the column on the left. The far left is people that had no additional exposure. In other words, they worked in the shipyard but not around nuclear things. And you could see they had the average population death rate. The one on the far right there is people that had the most exposure. That they had a 24% decrease in mortality from all causes. And the only difference between them and the ones in the black side were that they were in the radiation area. They were hired out of the same pool. Okay, real quick, ugliest building in the world. This is a apartment building. There's 1,600 of them that were built, and they had cobalt steel that was contaminated with cobalt-60. And so all these people live for like 9 to 20 years in these apartments being constantly radiated. But it was at a low level, and that's where we would expect a hormetic effect. Here are the figures that were published in the American Journal of Physicians and Surgeons. Expected over there is the number of people that would have been expected to die had they not been in the building at all. The higher one is what the LNT would say that the number of people that should have died. And the actual ones are over on the far right. Now, I wish they'd fudge this data because that looks so good. It's scary. It makes you think that it couldn't be that good, but that's the data. And they also looked at congenital malfunctions, malformations, and it was the same thing. We had an expected, we had a projected because of the additional radiation, and then we have an observed. All right, this was the title of my book. The publisher thought maybe it might be appealing to the wrong people. We changed it to this. Okay. Just 2 more quick slides. This was sent to me by a French environmentalist who's also a nuclear power advocate. It shows the volume of vitrified waste for a French family of 4 for 30 years. If you talk about wastes, nuclear power is the best thing going for you. And finally, if you want more radiation, I got to give this lady that runs this mine, this is a radon mine. It's in Boulder, Montana, where people, particularly with arthritic problems, they go and they stand there for a few hours and they come up and they read whatever. Anyway, she bought 200 of my books last week, so I'm giving her a little free spot tonight. But
But are they glowing?
Pardon?
Are they glowing?
Oh yeah, they'll come out of there glowing. That's right. Those are glowing people in there. Well, anyway, what I've hoped to have addressed is that this bugaboo about radiation being so dangerous is not true. We're just afraid of it because we don't understand it. If we look at the facts and the statistics about it, we find out that first, this problem of nuclear waste and this problem of evacuating areas around a power plant are just total hogwash. We just need to understand that the levels that they're talking about are so infinitesimal that they're insignificant in the scheme of things. Anyway, thank you, sir.
Thank you.
Thank you, gentlemen.